can't continuously record this video because I only get like 15 minutes, so I can't do a whole class period. YouTube won't allow me. So that's why I have to start to stop this. So microwave background, that means that there should be a glow that fills the universe. Microwaves are made of a type of photon, and these waves can be found in electromagnetic spectrum like gamma, X-rays, radio. The third point of evidence would be the mixture of elements. Stars have elements created from other stars. Basically, it's the origin of smaller matter defined here, that is smaller than what can be found in stars. And then the last point of evidence would be looking back into time. Galaxies a long time ago were quite different than today. Now, if we look at the last point of evidence, you must remember that the Big Bang Theory says what about time? It says that time has a beginning. Write that down. Remember, the Big Bang Theory says time has a beginning. It has a beginning because it says that matter has a beginning. And we talked about, in order to calculate time, you have to have matter. Like a car traveling over a certain distance at a certain rate of speed gives you a time. If you don't have a car, you don't have a distance, you don't have space, you can't calculate time. Is everybody clear? Good. Alright, so if we look at the timeline, that leads us to the timeline over here on the board, right? So let's say we are right here on the timeline. What we're doing with the Big Bang Theory, we are doing an interpolation. So there's a lot of data in the universe we can look at that goes back, just like you're saying here, galaxies a long time ago were different. So that's interpolation. So you get to a point where then it becomes extrapolation. And why does it become extrapolation? Anybody know? It becomes extrapolation because the Big Bang is considered to be a singularity. It's considered to be a singularity. And for this reason, the Big Bang is not a reliable theory. Reliable theories have to be repeated, tested. So it's not reliable. So a singularity means it only happens once. Now, if you're doing data in a lab, you get a singularity, and everything else is the same, you typically throw out the singularity. Just look at the TED Talk. Now, TED wants to bring everybody up to the singularity, and then make everybody equal to the singularity. But singularities by themselves, you can't repeat them. So they're not reliable. Also, it is not mass supported. What does that mean? Well, if you go to a calculator and you take 5 divided by 0, you're going to get math error, because no amount of 0 will fit into 5. Now, Google supports the Big Bang Theory, so they're going to say infinity. They're going to say an infinity amount of nothing will fit into 5, because they think nothing and something are the same. Alright, so the conditions can't be repeated. It's not math supported. The math basically falls apart before you get there. Conditions will never be known. That's the bigger thing about the singularity. You'll never know what the conditions are. So if you're in a lab and you're trying to repeat it, you're never going to know what the conditions are. If you don't know the conditions, they can't be repeated. And the last thing here is that emptiness can't be tested. According to the Big Bang, you have emptiness, then you have nothing is created out of emptiness, and then you have matter. So I'm going to write that down. You have emptiness creates nothing, and then you have matter created out of nothing. Now this matter out of nothing is called ex nihilo, and we'll talk about that on Tuesday. There's a lot to talk about. I can't do it all in one day. But this nothing making something is called ex nihilo. Now, a theory is an educated judgment. We talked about that in chapter 1. And a theory is successful if it can be used to make predictions that are true. So, truth must be opposite of lies, right? So in the universe, this Big Bang Theory says there are no opposites. So if you're producing a theory that predicts there are no opposites, I'm not sure how you can have truth then. You can't. It's not possible. All right, so everybody talks about the Big Bang, but there's also an end to this, and it's called the heat death or the Big Crunch. Concerns the end point of the universe. And I'm using Wikipedia here because the Big Bang was proposed in 1929. It's less than 100 years old, so a lot of people are still kind of uncertain to publish what they really think the end is going to be. You've got anywhere from the Big Rip to the heat death. But the most important thing I want you to see here is that the end state of the universe is a singularity. That's what's highlighted there. Let me see if I can hit the light. You might be able to see it a little bit better. Yeah, the end state of the universe is a singularity. So it relates back to the starting state being a singularity, in that you don't know what the conditions are, and you never will. We do have the longest shot so far today. Looks like it's at 1,073 centimeters from distance of star. Job, redshift of galaxies, expanding universe. These are the bellwork notes. Second part of today's activity concerns making airplanes and following a procedure and doing the write-up. This came from the American Association of Chemistry Teachers. Our first thrower is going to be Rain. Do you have your lab write-up paper? Here's the lab write-up paper. They have to complete. Then we will record their best 3 distances. Go ahead. Nice. So we got 501 centimeters, 501. So the two opinions on the redshift, the tiny dot basically says the universe is expanding everywhere from one point, and everywhere at once basically notes that the universe is not expanding from one central point. That's our current evidence. We do not notice that there's one central point in the universe from which everything is expanding. In conclusion, the scientific method will never be used, or will never be able to use the scientific method to verify the Big Bang Theory. So students were assigned bellwork homework to define the 4 points of evidence that support the Big Bang Theory. So we have the 4 points of evidence up here. The first point would be redshift of galaxies, expanding universe from a tiny dot or everywhere at once. Now this theory, the Big Bang Theory, is a fairly young theory. What year was this theory proposed? No. I gave you a timeline yesterday. I just seen it through it. Raise your hand, the Big Bang was proposed in 1929. So there's still a lot of thinking about it. But we do need to know the points of evidence, right? You should leave high school. If you're talking about the Big Bang Theory, you should at least know the 4 points of evidence for it. You've heard about them. We talked about evolution and that it's a reliable theory based on parthenogenesis, and that parthenogenesis is where you have a female queen bee that lays an egg, and then that egg forms a male, and for humans, that would be the 23rd chromosome going from X to Y, and that would be a change in chromosome number and change in type, because in the reproductive organs, based on meiosis, you have haploid chromosomes, and for them to increase and not divide, that would be an increase in number. All right, so the second the second point of evidence, can anybody read that? Scroll up. is what? Raise your hand. All right, let's go with, all right, Cody. Microwave background. So we have microwave background. Once again, the Big Bang is the theory that's supported in science, and we shouldn't be biased towards ideas in science. I mean, we shouldn't be prejudiced towards them. We should always be prejudiced toward what the definition of science is, and that is to determine what the truth is. If we start being biased things, then we start overlooking things, and we start accepting things that are not true, and that ends up being bad science. So we don't want to do that. So the Big Bang was actually published or submitted by George Lemaitre in 1927. I had 1929 earlier on the board. It was actually 1927. You got caught by the door. Looks like, we'll say 895. Which is pretty good. 895. Couldn't crash into the door. Your last one here? And we got, looks like 885. Carlos got 1173.
I don't care what Carlos got.
I
don't care what Carlos.
All right.
Was it only us out here right now? Yeah. It's all Alright, Coach, I'll be waiting on you.
He's waiting on you.
Seriously? Oh, okay. Oh, that was hot. Oh, dang.
In this Big Bang theory. Because if you look at all the other theories on the cosmological timeline, none of them have emptiness in it. So the Big Bang is really in the singularity of itself because it has emptiness. Most of them go with the Ex Nihilo concept of a finite universe, and we'll talk more about that next week. But the question is, why would they pull emptiness into this theory? Okay, some people kind of pull in faith to what they think. So if you put emptiness in there, now you have a trinity. Y'all see the trinity? Big Bang trinity? You might name the Big Bang trinity?
Yeah.
What's in the Big Bang trinity?
Extrapolation, emptiness.
Emptiness. Emptiness is part of the Big Bang theory. Nothing, which would be empty space. And then you have matter, right? So you have these three things. You have basically emptiness, and you have nothing, and then you have something. Okay? Now some people think there's a kind of a combo going on there between nothing and something, like they think that energy moves and it's nothing. And they're studying this because they want to prove ex nihilo, that nothing and something are the same. That's why you go to Google and you see, 5 divided by 0 is infinity. So some people believe that moving energy has no mass, and it's the key to finding the relationship between something and nothing as being equal. Is everybody clear? So a lot of people believe something and nothing are equal.